Hello, I'm Papia. In this problem, we have to use a graph to compute some limits. Now the graph is right here. As you can see that the function is a straight line. We don't know the equation of this function. That's okay. But there are some other information given to us. For example, we have this point on the graph 3, 1, and we also have that c is equal to 3. We have to compute limit of this function as x is approaching to c from the right side, from the left side, and from both sides. And finally, we have to discuss the continuity of this function. So, let's start with computing the limit as x approaches c plus, and you know plus means x is approaching c from the right side. Since we know the value of c already, let's write down what c is. So we have to evaluate x approaching 3 from right side and the limit of the function. Okay, so come back to the graph and let's think, how do we evaluate such a limit? Well, what you have to do is, you notice x is approaching 3 from right side. So you look at the function as x is approaching from this side of 3. So that means x is taking these values that are very close to 3 but greater than 3, to the right side of 3. Okay, so imagine x is slowly picking up these values, getting close to 3. What is happening to the function then? So what is happening to the y value? See, the function is approaching along the line from the right side, right? So the function will be approaching to this point right here as x is approaching 3 from right side. And what is this value? We are looking at the y value. Where is the function approaching? The value is right here, 1. So function is approaching to 1 as x is approaching 3 from right. And therefore, the answer is the y value, 1. So you see, this is the concept, right? So when we figure out, when we try to compute what happens when x approaches 3 from left, we do the exact same thing. Okay, so that's part B, right? We are evaluating limit of the same function f(x) as x approaches to 3 with a minus sign, means is approaching to 3 from left side. So come back to the graph and let's see. Now you are considering x is following this x-axis, getting close to 3 from the left. So it's picking up values close to 3 but smaller values than 3. And you have to go back to the function and see what is happening to the function. Notice as x is approaching to 3 from left, function is slowly approaching to this same value, the same y value. Y is 1. So from left side, the left side limit is exactly same as the right side limit, and that is 1. So this answer is 1 as well. Okay, so the last one is what is happening as x is approaching to just c. If there is no plus or minus, that means you are looking at the two-sided limit. So x is approaching 3 of the function f(x). How to determine two-sided limit? Well, you can look at the graph and see what's happening if x is approaching 3 from both sides, if the function is approaching to the same value or not. In this case, we have seen that from both sides, it's approaching to 1, and therefore, that is the limit. 1 is again the answer. Okay, so we're done with evaluating the limit as x approaches c from either sides. Finally, we have to decide the continuity of this function. What do we know about a function is continuous or not? You know, the easiest way to look at the graph and see if you can draw the graph of the function without lifting your pen, then the function is continuous. Now, you know that is the case for a straight line, right? You keep on drawing. You don't have to lift your pen, right? The other way to look at it is actually the definition of continuity, and that is you look at continuity at each point, each x value in the domain of the function. So if you pick any random x value in the domain, say 3, you look at the limit of this function from both sides, if that limit exists or not. See, in this case, we see that the limit is 1. It does exist, right? And what is the value of the function at 3? Also 1. So if the function value equals the limit as x approaches to that point, function is continuous at that point. And you can do that for every point in the domain. It doesn't have to be just 3. It could be anything in the domain. And if you note that this particular function from the graph, as we have discussed already, that you can draw it smoothly without lifting your pen because the limit exists at every point equals to the function value, and hence the function is continuous everywhere. So f is continuous at every x in its domain. And what is the domain of a line? Is every real number, and the domain is all real numbers, which means this function is a continuous function for every x value. That concludes the problem. Thank you.